All right, so for this lesson, we're going to be talking about a phenomenon called resonance. So let's consider this Lewis structure, ClO2 minus. You might be wondering what the minus is about. The minus means it's an ion, so you're going to need to add electrons. It's negative, so electrons have been added. So first, let's draw it like any other Lewis structure. So we know that Cl has 7 valence electrons, oxygen has 6, and there are 2 oxygen atoms. So that's going to give me 12 valence electrons. And this extra electron, we'll just call it E, we'll put 1. All right, so as a total, we're going to get 18 valence electrons. So you draw the basic structure, like we've done before, put a bond to everything, that's going to use up 4 electrons. You end up with 14 left. We start putting lone pairs everywhere, so 2, 4, 6, 8, 10, 12, excuse me. And we're left with 2 electrons left, which we put on the center atom. Now, if you look at the center atom, you'll see that it does not have an octet. The outer 2 atoms do have 8, but the center atom only has 6. So what we're going to need to do is find a way to fix this, and the way to fix this is by making a double bond. So I can make a double bond on the left by taking a lone pair and converting it to a double bond. Now the obvious question would be, what if I had taken from the right side instead? What if I had done this? Is there a difference? Does it matter? And the answer is that it does matter. All right, these are called resonant structures. What this means is that the actual structure is a combination. All right, the actual structure is a hybrid of both existing resonant structures. So don't think that the molecule flips back and forth. It's a very common conceptual error. The molecule does not flip back and forth. The molecule exists as a combination of both Lewis structures. When you actually measure the bond length, you find that the bond lengths are equal. So the actual structure is a hybrid. So knowing this, on the worksheet there are several resonance structures I want you to practice drawing. So the other thing you need to be able to do with this activity is find out something called formal charge. So let's now take a look at formal charge. So I'm going to erase this. If you missed something, you can go back in the video and watch it again. But let's go back to our example. So formal charge is a measurement of the electrons in a compound. All right, it's a formula. So formal charge is equal to the number of valence electrons on the atom minus number of bonds minus number of lone pair electrons. All right, I'm using E minus to represent electrons. All right, so let's go back to our Lewis structure from before. Let's do this one. Oops, there's a lone pair right there, and there are 2 lone pair on the outside. So formal charge has meaning only for specific atoms. So let's look at the formal charge of this one, and this one. So the formal charge for the oxygen will be as follows. Oxygen has 6 valence electrons, that's the first part, minus 1 bond, right there, minus 6 lone pair electrons, 1, 2, 3, 4, 5, 6. So the oxygen is going to have a formal charge of minus 1. So this is 1. 2, the chlorine in the center, the formal charge is equal to 7, the number of valence electrons, minus 3, the number of bonds, minus 2, the number of lone pair electrons. So when you measure, you're going to get positive 2. Number 3, the oxygen on the far end, the formal charge, is equal to the number of valence electrons, which is 6 for oxygen, minus the number of bonds, which is 2, minus the number of lone pair electrons, which is 4, gives me a formal charge of 0. So as you can see, you can find formal charge. Let me lower this a little bit. You can find formal charge for any one of the species. So since the camera was a little bit out of frame, let's just go over this real fast. 7 valence electrons in this example, minus 3 bonds, minus 2 lone pair electrons, looking up here. So set 3 bonds, 2 lone pair electrons, it's right here, gives me a formal charge of positive 2. 6 valence electrons right here on the oxygen on the right, minus 2 bonds right there, minus 4 lone pair electrons, 1, 2, 3, 4, gets me a formal charge of 0. If you're doing the worksheet and you have questions, please send me a message on Teams. But otherwise, You'll have this activity in place of the Plato activity that the rest of the class will be doing Thursday and Friday.